Okay, so now we do example 4 and do what's called the break-even analysis for the profit function that we found in example number 3. I just want to remind you, you should reference the document over the graphing calculator that is on the My Math Lab. Go down to the tab that says the graphing calculator and then click on the document that is entitled the graphing screen. In that document, you will learn how to set the window, how to find an appropriate viewing window. It will also show you how to use the zero feature of the calculator to find the zeros of a function. And there it also will take you through an example on how to do the how to find the zeros and how to find the maximum. Okay, so from example number from example 3a above, we found that the profit function capital P of x was negative x squared over 80 plus 130x minus 210,000. Now, the important thing is that we stated that this profit function was valid on this interval from 0 to 12,000. And that's going to play a huge role in when we go to graph this function. Now, before we actually look at the graph, I do want you to keep in mind that you should have already had an idea what the graph of this function was going to look like. If you look at this p of x up here, notice the highest power is 2, which tells us the graph has to be a parabola. In fact, since the leading term is negative, it tells us that it's a parabola that opens downward as viewed over here in this graph. So this is what we expect to see on our graphing screen on our calculator is a parabola that opens downward. Okay, so knowing that the parabola is going to open downward, right away I see that there's going to be two places where the the uh, the parabola is going to cross the x-axis. Those right there are my break-even points. So first, let's set the window. As I set the window, notice that I go to the window, hit the window button on my calculator, and I type in for x min 0. X max is 12,000. And where did these numbers come from? Well, they came from the interval that was given. You always set x max to the biggest number, the right endpoint of the interval, and the left endpoint, which in this case is 0, that's what you make x min. Now what I try to do so that there's not, so now I know that if I look at this graph over here, my calculator screen is going to go from x equals 0 all the way out to x equal 12,000. But what I got to do, I have to set the scale so that there's not all these 1,000 points showing up on my calculator screen. So I set the X scale to 1,000. And what that does for me, now I know that each tick mark on this x-axis, the very first tick mark here is going to be 1,000. The second one is going to be 2,000 and so forth till I get to the end of the window, which is 12,000. Okay, and again, you see where I got X min and X max? They came from the endpoints of the interval that was given. The scale, I just produced a scale so there's not too many points on the screen. I didn't want more than 12 points to appear along the x-axis. Now to get the y-axis, the y settings, I use a zoom fit feature of the calculator. So I hit the zoom button, which is the third button underneath the screen on the calculator, and then I go to the appropriate uh, button that says zoom fit, and what's going to happen, the calculator is going to sketch the graph of this parabola over the interval from x equals 0 out to x equals 12,000. And then what I did, I centered my graph horizontally, I'm sorry, vertically, by picking y min to be negative 5,000, and I set y max to be, I'm sorry, y min was negative 500,000, while y max is positive 500,000. And again, so now my screen over here is going from way down here from negative 500,000, somewhere down here, all the way up to 500,000. Now, the way I pick these numbers, what I want to do, I want to make sure that I don't cut off the, the top of the parabola. So I make this Y max large enough so that I can fit the entire parabola on the screen. And the choice of negative 500,000 for Y min, that just centers my graph vertically. So again, I don't want too many points along the y-axis, so I use a scale of 100,000. So that means that the first tick mark on the y-axis here will be 100,000. The second tick mark will be at 200,000, and so forth. Okay, so now that we set up the window, this is the graph that we get on our viewing screen. As I mentioned earlier, this right here is the first break-even point, and this second one is the second break-even point. Notice that they're both inside the interval from x equals 0 out to x equal 12,000. So I use the zero feature of the calculator as it states here, and I find the first zero, and it's 2,000. Then I use the zero feature again and move over a little bit, and I put an interval around. I go from, let's say, from 7,000 to 9,000, and the calculator produces a zero of 8,400. So those are my two break-even points. Call it x sub 1 is 2,000, x sub 2 is 8,400. So remember what this means, if I were to plug in 2,000 back into this profit function, I will get 0. Now I also know that if I put 8,400 in here into the profit function, I also produce 0. So if we want to find where the profit region is, then I just got to find where the graph is above the x-axis. Well, as you can look here on the graph, you can see that the graph of the profit function is above the x-axis whenever x is a number between 2,000 and 8,400. So notice how the profit region is written here. It's got parentheses on the ends of the interval because the reason I don't use a square bracket, let's say around the 8,400, because at when 8,400 is plugged into the profit function, I get 0. I don't get a profit there. So it's an open interval with parentheses. The loss region, you can see the loss region is where the graph is below the x-axis, and it's below the x-axis in two locations. So notice the square bracket here, because when I plug in 0 into the profit function, I get negative 210,000, which is a loss. So it goes from square bracket, 0, and then a parenthesis on the 2,000. And again, I go from parenthesis 8,400, not to infinity, but to 12,000 because the profit function is only defined out to 12,000 as it says right here. So there, we have done a complete break-even analysis. We stated the break-even points, we stated the loss regions, and we stated the profit regions. One final note, I can use the maximum feature of the calculator, just the way the zero feature works, and I can determine the maximum profit for this company in a given month. So it turns out to be that the profit, wanting the y coordinate of this top point, the vertex, occurs at 5,200. So it says, as it says down here, when TVs R Us sells 5,200 TVs in one month, they make a profit of $128,000 in a given month. This $128,000 is the y coordinate of the vertex. I want the y coordinate, that's the maximum profit. The x coordinate of that vertex, the 5,200, tells me what production level to be at to maximize that profit. So as it says down here, When TVs R Us produces and sells 5,200 TVs, they will make a maximum profit of $128,000. Be sure to do the example on page 3 of this handout, and the answers are on the bottom of the handout there. Okay.